my name is Aleksandras. I've been well introduced already, but anyway, I work with Scraper APIs and WebUnblocker, and today I'm going to talk about the Oxy approach to applying AI to scraping. Now, let's start with some basics first. If you want to work with web data, you'll have to concern yourself with most, if not all, of these activities. That's finding URLs you want to scrape, right? URL discovery, done by crawling the site or generating URLs if you're lucky. Scheduling your scraping requests so that the data in the URLs you want to scrape keeps on updating, right? You want to work with fresh data. Avoiding blocks, that's a big topic, right? And can be the most difficult part in your scraping journey. In some cases, you'll have to interact with the website to make it return, well, good content to you or make the content load onto the page, right? And finally, it's all worthless if you're not parsing your HTMLs and turning them into a CSV or JSON structure. At this day and age, you may want to turn to an LLM model to generate the code for all of these steps. Or you may want to work with an AI agent and just give it the task of just doing all of this and getting to the end of just, end result of you having the data. Now, however, the problem is that scraping code generated with LLMs is prone to errors and expensive to scale. It's not that well optimized. Because LLMs, also have issues with hallucination, with not providing, dreaming up, the parameters that should be very precise. So we at Oxylabs, we recognize the shortcomings of LLM-generated code, and also right now we're not starting from scratch and have already built a variety of robust services made available via an API. And so our solution is employing these microservices written in the traditional way by developers and building an AI-powered abstraction layer on top of them to make it easy to use these services. Now, what do I mean by the AI-powered abstraction layer? I'm sure you'll find out. So let's start with the first step, that's website crawling. So the problem with URL discovery and website crawling is, how do I even know what URLs I want to scrape on a given site, right? So you have to do some crawling and figure out what URLs are present on that website. Now, crawling at scale is tedious work. Every site is different. Lots of custom solutions. If you want to crawl multiple sites and you have to optimize your crawling solution so that you don't go out of budget, scrape too much, and spend too much time, right? So our solution here with Oxylabs is, and that's what we offer to you as well, is you can use our web crawler feature that's part of our web scraper API platform. It works on any site. It lets you define the optimal crawling path by using filters. And you can see the filters on the screen right now, so I'll just quickly go through them. The crawl filter lets you define the regex for the URLs you want to open as a part of your crawling process, sort of, while looking for more URLs to scrape. And the process filter defines the URLs which are useful to you, which you want to keep as the end result of this whole crawling operation. Of course, you can define the max depth parameter, which makes us basically stop after getting to, so many URLs from the starting point. Of course, you have the max URLs parameter too, which just makes the crawler stop after it scrapes a given amount of URLs. This lets you control your budget. Now that we've spoken about crawling, let's talk about request scheduling. The problem is that you just need your data fresh. You want it refreshed every day or every so often. But this means building a separate service and keeping it running. You have to maintain it. Of course, the big cost is in maintenance, not the initial building. So with Scraper APIs, our solution here is, we just have a scheduler feature that's available as part of our web scraping API platform. You can simply define the frequency you want your data updated at by using the cron expression. You send us an items list which contains job descriptions, scraping job descriptions, right? Which we will execute at your given frequency. And of course, you can include an end time at which you want to stop the request scheduling. And here it's set to like 8 years from now. So this way, you don't need the request scheduler on your side. You can just submit this one API call to us and get your data delivered to your cloud storage on regular time intervals and just work on the data. Sounds great, right? Now, let's talk about the elephant in the room and not getting blocked. I mean, the problem here is no matter what you do, I'm sure you've been in this situation. If not, you're very lucky. No matter what you do, you get blocked. And yeah, to those of you who are that lucky, I've included a nice picture of a CAPTCHA. I'm sure most of us do know what a CAPTCHA looks like. We get that regularly, right? So yeah, so that's the problem. You get blocked. So the solution, of course, is managing all aspects of fingerprinting. That's the TCP/IP, TLS, HTTP, JavaScript, and behavioral layers. That sounds like a lot of work. That's because it is. So yeah, so the solution really I'm proposing here is you can use our Web Scraper API platform, which employs dynamic scraping strategy discovery system for dynamically switching between strategies, an AI-powered block detector for result validation, a smart proxy manager, which we've patented, which rotates the proxies in an optimal way, and an AI-powered CAPTCHA solving engine, which we are slowly and gradually introducing as part of our service. So honestly, just let us do the heavy lifting here. Now, let's talk about Headless Browser. You may have to use a Headless Browser to scrape a page that dynamically loads content onto the document object model. And you may also have to interact with the page to make it give you the content that you're after, basically. So, well, there are a couple of problems here. Of course, yeah, you have to have some JavaScript or Chrome developer protocol knowledge to just get started. But also with browsers, it's hard to scale. When I say hard, I mean expensive, right? It's just, yeah, it's hard to find an optimal solution here. So our solution, surprise, is using the Web Scraper API platform and its Headless Browser feature. It just offers no-frills JS rendering. As you can see, the payload here. You give us a URL, ask us to render the JavaScript, and that's what we'll do. No, you don't require any extra infrastructure because headless browsers are run on our side. And of course, you can easily customize your browser interactions with browser instructions. So let me show you that. Here's another payload example. With this, we include a set of, well, just a single browser instruction, really. We're asking the headless browser to open the page, render JavaScript, and then click on the button that says Add to Cart. And what that makes, what that does really is, well, on Target.com product page, after you click the button, it shows you the delivery information. So there's no real other way to get that information other than just clicking that button. So this works great. It's part of our platform, and you're free to use it. Of course, you can string a few of these actions together to make more intricate scraping workflows possible. That's super easy. Now let's talk about parsing. Because, like I said, it would be meaningless if you just scraped the web and didn't do any parsing. So the problem really is that parsing is repetitive work and a tiring task. It's manual, mostly. Different selectors. You may need to have to find different selectors for the same data point on the same page type on a website if you have different layouts. And of course, you need to maintain all of that because layouts do change, and with them, your parsing goes broken. The web scraper API platform has a couple of solutions in this space. First of all, we have our dedicated parsers. Just for some really popular page types. You give us a search term for Amazon. You say parse equals true, and then we'll parse the page. Awesome. However, for some page types that we don't have dedicated parsers for, what we're able to offer is you can send us your own parsing instructions. Here you can see I'm scraping example.com, and I'm asking to parse the title, and that's done by selecting the H1 element. And of course, these parsing instructions can get much more complex. And you can have nested objects within lists and things like that. So now that we've spoken about the parsing bit, how does it all tie in under the AI abstraction layer? The services I went through are quite powerful. However, it's not that difficult to get yourself lost in all the possibilities of our platform. You may know we want to get done with our scraping platform, but configuring all these services to do just that can take a while. You may have to write hundreds of lines of code to make the most of our platform. If only you could just describe in plain language what you want to get done and get us to do it. Well, today it's my honor to introduce OxyCopilot, an AI. OxyCopilot is an AI-powered tool that ties all these pieces together and lets you, work with our service in a simpler way. So, OxyCopilot features natural language input. It's simple to set up and then modify. It makes it easy to leverage the whole web scraping platform. So I'm excited to show you how it works. So if you just give me a second, I'll start my machine up. Right, so you can see my screen. So if you go to our dashboard, you have the API playground. And there, you already have all of this. It just appeared a couple of hours ago. So what you can do is you can click here, enter a URL you want to scrape. So let's take something from, let's take an example here, a real URL. Describe your requirements for your scraping. I'll be very simple. I'll say just scrape the URL with a United States location. Okay. Now we're just submitting that. And OxyCopilot is going to think about what we just said, and hopefully, get back to us saying that it's all done. So, I'm sorry, I'll just do it again. It's generating the integration code for the scraper. So just give me, continue without parsing. And here we can see, like we just set this location, and we got the URL already here too. So what you can do with this is you can just copy it out and use it as your payload. But that's like a very, very simple sort of showcase of what this part can do. We're just setting the location here. This tool is trained on our whole documentation. It can understand like various page types and sources and whatnot. But the thing I really wanted to show you here was the parsing instructions bit. So now we're clicking the add parsing instructions, and we're going to build our own parser. And that won't take too long, I promise. So let's create one with AI. Okay, so in this step, I'm going to give 3 URLs for a Zillow.com listing page. Just quickly have a look at what that looks like. So we've given it a few of these URLs, and then we should enter a description of what information we want to get extracted. So in our case, I'm saying parse property price, address, built year, description, and square footage. And I'm clicking generate instructions. So this may take a tiny while. So anyway, what's happening behind the scenes is we're using our scraping platform to first gather the HTMLs. And then those are going to get sent to an LLM so that it makes sense of, of the data in the HTMLs, and also takes in our prompt that we wrote there. And then, with a bit of luck, we're able to get to a point where, we are getting a set of parsing instructions. So here you can see we've generated the parsing instructions for the price, and there are a few XPaths here, and also, regex search. I won't be able to explain this, but it just does it automatically. We have the address again and the parsing instructions for that. The build here and whatever else. So let's save these instructions and try to run them on the URL we haven't trained this on. So making another request, and now in a few seconds time, we'll get a response that, of course, contains the parsed output of what we wanted to get. So this is how quickly, how much time it took for us to just generate a parser for page type we haven't worked with before. So I hope that's at least a tiny bit impressive. Yeah, okay. So let's show you a couple of more examples. Just deleting this, refreshing the page. I'll go create a parser with AI. I'm gonna give give it some other URLs to work with. This is a bike shop. Let's have a look at what this page looks like. Yeah, just some cycling stuff, a product page, in its essence. So what we want to do here is give it a bit more work, because the previous example is just, a simple parsed output structure. So here we want to parse a product title, price, the title, frequently bought products to a list of objects that corresponds to these products here. Each of the frequently bought products should contain price and a title. So let's see how well we handle that. Long drum roll. Thanks. Okay. So like I said, we're scraping the URLs, we're cleaning the HTMLs, we're sending them to an LLM, along with our prompts, getting the selectors back, and generating the parsing instructions that include those selectors and additional data mangling sort of parameters. Okay, well, this didn't take too long. Now we've got our output. Just gonna click Save Instructions. And now we're gonna run these instructions on the URL we haven't seen before. Not one of these URLs that I used as the initial input, right? A new URL. So now, even though it took a while, well, I don't know, half a minute to generate the parsing instructions, parsing a page, a new URL that we initially didn't have, took just a few seconds, right? So the generating parsing code is what takes longer. But then once you have the parsing code, you can employ our scraping platform by just passing the parsing instructions. You can see here that have been generated and getting a quick response from our API. Okay, so ready for another example? Yes. Let's start anew. Okay, add parsing instructions, create with AI. And we're going to do a Lithuanian side, actually, because you may think that it only works with English language and whatnot. So, we're still going to do our prompt in English. So we're parsing property title, the price, description. We're asking it to parse the most popular searches, which is under the section populiariausias paieškos, and add them to a list. So we got the URLs here. Let's make sure that, yeah. Generate instructions. You know, someone presented, you know, the project where they scraped Lithuanian, property prices and availability. So I guess this simplifies their work too. So I'm glad we're at that point. So yeah, just give it a few seconds. It'll give us the parsing instructions. And like, it's really easy to get started. You don't need to know any programming language, anything like that. Our OxyCopilot is able to generate the parsing instructions for you, and then you just take those instructions and send them to our API as part of your API payload. And of course, you have to send the URL that you want the data extracted from. But really, you know, that's all you need to do to get structured data from our platform. So, yeah, just let's check if this works on the URL we then use for generating those instructions. Yeah, is it? Okay, well, yeah. Like I didn't say, this is a beta that's available to all of us as of today. So we want everyone to try this out. It may go sort of awry sometime, but it gets a lot of stuff right, you know, too. If you're happy with what it does, feel free to use it. If not, rest assured that we sort of, you know, analyze what prompts you submit and how well they work. So then we are able to improve upon your experience and just give you better results. Well, yeah, this is just giving us the old ML parser outputs that we had. So anyway, this is what I had to show in terms of the OxyCopilot demo. It's live now. It's free of charge. It lets you integrate our scraping platform with a breeze, and we'll work on expanding the Copilot capabilities so that you can work on the data instead of trying to work with extracting it. So with this, I'm ready to answer any questions that we may have. Thank you.
Thank you, Aleksandras, and the OxyCopilot is so exciting. Oh my God! So now I see that we already have a lot of questions,
wow. Yeah.
And we'll get started with: is it possible to use Web Scraper API with low-level requests? For example, making post requests and just gathering JSON responses.
Yeah, I mean, if you have a URL, you know, I like to say. You bring a URL and we just scrape it. Like you can give us any sort of URL, we'll just deliver you the data that's at that address.
Okay.
Yeah.
And now a bit of an inside scoop. I don't know if we can say this, but maybe. What LLM models are you using for this?
Yeah. Right now, it's I think it's the OpenAI one, but we've tested a few models and we keep on benchmarking them to see which one gives the best accuracy and the best performance for our customers.
Okay. And what was the biggest challenge while building this feature?
Yeah, one of the challenges has been just fitting into the context window because you have to clean the HTML. You cannot send it as a whole, right? So figuring out how to do that was a big part of this.
Yeah, but it's your daily job, so it's okay. How do you manage large-scale scraping, like getting Walmart 4K stores data?
This is a complex subject, right? So like I showed in like a few slides back, there's no shortcut around it. You have to understand the way fingerprints work and how the site detects you. And like on sites like Walmart, you do have to sort of, make the fingerprinting layers work together well. Like if, what I mean by that, if you're sending a user agent, that corresponds to Chrome browser, that has to be matched up by your TLS on your TLS fingerprint layer and things like that. Just ensuring that your fingerprint as a whole looks good.
Okay. And now, what if the HTML changes on the page? Will it automatically update?
It will not, but yeah, that's the truth. We've seen the selectors, but what you can do at that point will give you warnings that some data has not been parsed correctly. You notice that, you go to OxyCopilot, send it the same prompt, the same URLs, perhaps those in which the data you wanted wasn't parsed. It'll give you another set of parsing instructions, and you submit that right up our API, and you get your data again.
Okay. And this one is really interesting. Is it able to extract specific attributes inside a block? For example, extracting some particular number into a description.
Okay, so if it's a block of text, right now it's quite difficult to do that. Although there are at some point what you can do is you can take our parsing instructions generated by Copilot and modify them. So you can find you may be able to find your number within a description block by just using some clever regex. So yeah, you can do that for sure. It's on our roadmap to do that, more automatically too.
Okay. And now the last question. Does unblocking work when I am navigating through the website and I have navigated like 10 pages and want to unblock the 11th page?
Okay. So I guess what this is referring to is using sessions for scraping. And that definitely does work. Yeah, but then, you may want to think whether you want to see the 10th page of results having the history of seeing the first 9, because that's less likely to get you blocked. But it is more likely that the website will give you some kind of skewed results based on your browsing history and the 9 pages it served you before. So it depends on whether you want to get blocked less or you want to have the neutral browsing experience as the scraped result.